Today we began with you just figuring out what each place value was for each of these digits. And you guys could do that pretty well. The 2 is in the tens place, the 3 is the hundredths place, the 4 is the thousandths place, the 5 is the 10,000ths place, the 0 is the 100,000ths place, the 6 is in the millionths place, and the 1 is in the 10 millionths place. And then my big question was, how do you write each of these as a power of 10? And that's really the big idea of today's lesson, is other powers of 10. One of you knew how to do this. Max knew how to do this in period 6, which was awesome. So how do we figure out what those are? So we began by looking for a pattern, and the pattern you're trying to find out is, what does a negative exponent mean? And a lot of you saw that the exponent is just decreasing by 1 every time. So I asked you, what's the pattern with the numbers in standard form? What's the same to get, what am I doing to get from 1,000 to 100, from 100 to 10, from 10 to 1, from 1 to a tenth? And a lot of you saw right away you're dividing by 10. And that makes sense because this is 10 used as a factor 3 times. This is 10 used as a factor twice. So this 1,000 divided by 10 gives me 10 only as a factor twice. So 10 times 10 is 100. 100 divided by 10 is 10. 10 divided by 10 is 1, which is why any number except for 0 to the power of 0 gives us 1. 0 to the power of 0 equaling 1 doesn't make sense. You can't get 1 from nothing. So any other number, though, we could change any of these bases to another number, and they would follow the same pattern of dividing the number by itself when you get to this step. And 10 divided by itself is 1. So 10 divided by 10 is 1, so 10 to the power of 0 is 1. 1 divided by 10 is a tenth. So 10 to the power of negative 1 is just a tenth of 1. And then 10 to the power of negative 2 is a tenth of 1/10, or a hundredth. 10 to the power of negative 3 is a tenth of a hundredth, or a thousandth. I wanted you to look at the fraction form so you see a pattern. What the negative exponent really means is we have a number less than 1. It's not a negative number, it's just tiny, teeny tiny number. And there is a relationship between the teeny tiny amount when I have 10 to the power of negative 3 and the big amount when I have 10 to the power of positive 3. And we'll get to that in just a minute. So what's happening as you go down every one of these columns, whether it's exponential form, standard form, or fraction form, is you're dividing by 10 to go down the column. Or each number as you go down is 1/10 as much as the number above it. So dividing by 10 and taking a tenth as much are the same thing. So the next really important pattern for you to see is, how is 10 cubed related to 10 to the power of negative 3. So I color-coded it in red so you can see 10 cubed is 1,000, and if we write it as a fraction, it's 1,000 over 1. 10 to the power of negative 3 is 1 out of 1,000. Notice if I flip 1,000 over 1 upside down, I get 1/1000th. And there's a special name for that. Two numbers whose product is 1, which is what happens when I flip 1/1000 over 1 and I get 1/1000th. If I multiply these two numbers together, I get 1. 1,000 groups of 1/1000th is 1 whole. 100 times 100th is 1 whole. 10 times a tenth is 1 whole. So reciprocals are numbers whose product is 1. Two numbers whose product is 1. So notice that 10 squared is the reciprocal of 10 to the power of negative 2. So if 10 squared is 100 over 1, 10 to the power of negative 2 is 1 over 100. 10 to the power of 1 is the reciprocal of 10 to the power of negative 1. 10 over 1 flipped upside down is 1 over 10. If I multiply these two, I get 1. That's what reciprocals are. And 1, the only thing I can multiply 1 by to get 1 is 1. So 1 and itself are reciprocals. So just look at the pattern. Notice that all of these exponents give me, with 10, a number bigger than 1. all of these exponents give me a tiny number that's less than 1. It's not negative. It's between 0 and 1. It's never going to be negative. It's just going to get tinier and tinier and tinier. I'm going to keep putting in one more 0, one more 0, one more 0. But I'm never going to get to negative numbers because it's just getting closer and closer to 0 infinitely. So reciprocals. These two numbers when multiplied give me 1. These two numbers when multiplied give me 1. These two numbers when multiplied give me 1. These two numbers give me 1. So these are the same, and these are the same. So the reciprocal of 10 cubed is 10 to the power of negative 3. So if this is 1,000, this is 1/1000th. And then we talked about powerful patterns of 10. If I want to now multiply 5 times 10 to the power of negative 2, I just have to remember that 10 to the power of negative 2 is the reciprocal of 10 squared. So think of what 10 squared is. Flip it upside down. So now I want 5 groups of 100th, which is 5 100ths. Or 5 times 1/100th as a decimal is still 5 100ths. These are the same numbers. So then in your table groups, you just found the pattern for the size of all numbers that have an exponent that's positive. And what you found is they're all greater than 1. They're all big. The size of all powers of 10 with a negative exponent, they're all tiny. They're all less than 1. And any number to the power of 0 is 1. 1. Except for, remember, you can't have a 0 to the power of 0. That's not going to equal 1. If you try that in your calculator, you'll either get domain error, syntax error, or just an error sign. Because that's one of those things in mathematics that you can't do. So then I asked you, how is multiplying by a tenth like division? And you guys knew. 80 times a tenth is 8. It's just like dividing by 10. So dividing by 10 is the same as multiplying by 1/10. And that also holds for multiplying 5 by a tenth. 5 times a tenth is 5/10. 5 times 0.1 is 0.5. Those both say 5/10. It's the same thing as 5 divided by 10. 5 divided by 10 is 5/10. So just so you see that connection. All right, then we looked at for another patterns. There's a really excellent table, a blue table on page 30. If you study that, you'll see those same patterns in the table. So what I wanted you to look at, what's a quick way to multiply by negative powers of 10? And I said, look for a pattern here. So if I have 6 3/10 times 10 to the power of negative 1, notice I move the decimal once to the left because I'm taking a tenth of it. Now I'm going to multiply by 10 to the power of negative 2. Now I want 100th of it. So from 6.3, I move the decimal twice to the left. And if I multiply 6.3 times 10 to the power of negative 3, I move the decimal 3 times to the left, because this is 1/1000th, which is like dividing by 1,000. I'm getting tinier. And if I multiply 6.3 times 10 to the power of negative 4, I move the decimal 4 times to the left, because I'm multiplying by 1/10,000th. So I get 1/10,000th as much as 6.3. So we looked at, in general, if I'm going to multiply 6 3/10 times 10 squared, I move the decimal twice to the right because it's getting bigger, and I get 630. If I'm multiplying 6.3 times 10 to the power of negative 2, though, I move the decimal twice to the left, and I have to put this 0 placeholder in because I'm getting smaller. Here I have to put a 0 placeholder in for the ones place, and here I have to put a 0 placeholder in the tenths place. So remember, to get bigger, the decimal moves to the right. To get smaller, the decimal moves to the left. And then you did these with a partner, and I had people come up to the smartboard and fill them in. So just study these problems and their answers. Look at the way the decimals moved to the left when it gets smaller, to the right when it gets bigger, to the left when we're getting smaller, to the right when we're getting bigger.